Hello, good afternoon. My name is Mark de la Vieter, and I'm currently your host on the Energy System Integration webinar. I will do this together with my colleague, Martijn de Vries. The two of us are both employed at New Energy Coalition, both employed at the system integration part of our organization. I am the cluster coordinator for energy system integration and also an expert on large-scale system integration. My colleague Martijn will also present part of our activities. He's a senior project manager within our organization, and he is the expert on small-scale system integration and smart cities. We will present three things today. A first aspect will be a general introduction to energy system integration. I will do this, in which we will set somewhat of the scene and explain how, as New Energy Coalition, we're approaching system integration. During a second part, which consists of two parts again, we will discuss a little bit about large-scale system integration, which is all about looking at the North Sea, looking at large decarbonization, etc. I will do that, looking at ambitions, challenges, and solutions. And my colleague Martijn will do a similar thing for the small-scale system integration. First thing about energy system integration, because I would like to point out that there's a difference between energy system integration and system integration per se. Energy system integration is about integrating different energy systems. System integration can also include other aspects of a system, and that's a system in general that can be integrated. Duly noted that energy system integration and system integration as a whole are somewhat intertwined, as I will discuss a little bit later during the presentation on large-scale system integration. The first thing is, why are we doing this? Why are we doing system integration? I think that starts with our energy challenge, and it is we need to decarbonize our different end users. Normally, these are distributed among four different aspects: industry, roughly half, and then built environment, roughly a quarter, mobility, roughly a quarter, and agriculture, sometimes that's also counted towards industry as well, relatively small. This is the Dutch distribution, but this is highly similar to other locations in the industrialized world as well. The thing is that energy is not something that we finally need to use. And I think that's really important to take note of that, because it's just a carrier. Because what we want as a society are somewhat of a service or something that needs to be done. For example, we don't want electricity, we want, in this case, clean clothes. And we can use different carriers to satisfy this need. So currently, if you wash your clothes, you can use electricity. That's just putting stuff in the washing machine. But you can go for other approaches, like using hydrogen in a fuel cell directly. Another aspect is you can travel from A to B. Currently, that's being done using gasoline if you go by car, or jet fuel if you go by plane. But you can also use different carriers there. Same goes for a comfortable house, but also products like plastic cup. Currently, plastic cups are made using crude oil, but we can go to other aspects we can use for powered products. So, for example, using hydrogen as an intermediary, or we can go for plant-based materials. When starting with energy system integration, you should always take this in the back of your mind. It's the energy trilemma, because we want to achieve an energy system, and that's an energy system that can fulfill these four end users with all their demands, that is environmentally sustainable, is safe and is reliable, and is also affordable. And normally with a trilemma, it's relatively easy to do two things, but all three at the same time is really hard. So a sustainable and really secure system is relatively okay, but then it will become super expensive. The thing is that what we used to do is we had a one-way energy system, which was also going back to this, this trilemma, was affordable and secure. but not really sustainable. And now we're going to a more sustainable energy system, this integrated energy system, which is at least sustainable, but might lack in security or might lack in the third one, affordability. It can become super expensive. So the thing is, we also, and I also want to stress this one, we also have some challenges here, because if we're going for system integration, we have the three so-called mismatches. The first one is the mismatch in time, and this is mainly the case with renewable sources. That is, that you, if you have intermittently producing energy generators like wind, like solar, it's not necessarily the case that you can also use the energy at that time. That's the first one. A second one is that you have a mismatch in location. That's not necessarily for renewables, but it's for everything. You can produce something at location A, and it needs to be used at location B, which might lead to congestion on energy systems. And the final one is mismatching function. That is that you produce, for example, electricity or green gas, etc., but you need something else, like a heated house or a cup, a plastic cup, etc. Energy system integration is all about creating solutions for these three challenges, and all three needs to be met. Otherwise, we won't result in an integrated energy system that is cheap, reliable, and green, like mentioned in the energy trilemma. Different stakeholders have come up with different approaches to system integration. The first one is the EU. The EU is counting for 4 pillars as the pillars for energy system integration. It needs to be efficient and circular. We need to decarbonize our power system. We need to decarbonize our fuel system, and we need to create an energy market. This is highly in line with what I previously mentioned on that it needs to be affordable and you need to decarbonize the sectors, but it's just another cross section. As New Energy Coalition, we also have our, oh, sorry, I missed this one. We can, using system integration, we can solve many of the mismatches. Possible solutions are, for example, for a mismatch in time, that we can come up with storage, or we can come up with demand response, so using your washing machine when the wind is blowing. But we can also go for cable pooling. So that means that you both put solar and wind on the same export cable. So, and since solar and wind are not really producing at the same time, you solve your mismatch in time because they are really complementary. For mismatch in location, we can come up with that a little bit later. You can come up with, for example, a smart city that where you produce your energy as close to the consumption as possible. You can go for new approaches that will create a lower price for transport, so then the location won't be that much of a problem anymore. And for mismatching function, you can come up with all sorts of conversions or new approaches, also new integrated solutions that will allow you to create other functions as well. That was a sheet I was looking for. As New Energy Coalition, we're also looking at system integration in a way which is similar to the European Commission, but as New Energy Coalition, since we want to generate projects out of it, we have created this canvas with 3 different levels where system integration can play a role. On a local level, a regional level, and an international level. Today, we will discuss the international level and the local level. And we have 4 different aspects that need to be challenged on all of these levels. The end result, as shown to the right, is a decarbonized industry, mobility, built environment, and agriculture. The pillars, organization. The first one is how can we organize a system that will work, that will not be too expensive, where everyone will do the right things. A second one is about control. How can we create a system that is inherently safe and cheap, and that is also balancing supply and demand? A third one is access. How can we create an energy system that is accessible to everyone at affordable prices? And a final one is how can we go for new developments? And I would say that's somewhat of an umbrella term, because we need somewhat of a technical development in order to make things work. As New Energy Coalition, we want to develop projects on all of these cross points between the horizontal and the vertical approaches, because that will allow us to slowly progress into system integration. A little bit of discussion over here. The first one is about local system integration, so the bottom aggregation level. Challenge here is how can we generate enough energy, for example, in these tall skyscrapers? You don't have the room. How will we do this? Martijn will discuss this a little bit further. A second one is about the regional system integration. So that could be energy islands, energy ecosystems. That is somewhat of a plot, a little bit bigger in scale than a really local energy system, where you have all sorts of energy streams, waste streams, heat, etc., that can create an energy island. That doesn't have to be an island per se, but that's an energy island is a system where all streams are balanced and where there's no interaction with the outside world. A final one is about large-scale system integration. And there are two aspects to that. The first one is what I've shown to the right, is really big users of energy, in this case, a large steel factory, and on the other hand, a large generation, in this case, offshore. As mentioned before, as New Energy Coalition, we've got many projects on all different aspects. I've shown some of them. This is just part of our portfolio. You can see our full portfolio at newenergycoalition.org. So, for example, on international energy ecosystems, we have our North Sea Energy Program, which tackles all of these aspects, but aspect A and D a little bit more. We have on this mid-level, we have projects like Agriport A7, Janos, etc. And on this small scale, the one Martijn will be discussing, we have smart city projects like Positive and Making City. Well, this was a little bit of an introduction, a really short introduction on energy system integration. I'd like to continue with offshore system integration. Note that I left out energy system integration, because especially energy offshore system integration is more than just energy. It's about integrating a system, an offshore energy system, an offshore fishery system, sand extraction, etc., into one system, in this case, the North Sea. The North Sea is currently a really big producer of oil, fish, etc. But as a new development is that there's a massive ramp up of offshore wind production capacity, as shown over here. These are the 2019 figures, but in 2021 they're already like 50% higher. So it's a massive ramp up over here that we're looking at. But we're still far from where we want to be, because the ambitions are much larger. This will pose a threat. It will pose a challenge to integrating all different systems on the North Sea, because the North Sea is somewhat of a challenging location. For example, first of all, is how the North Sea is governed. This is just the Dutch North Sea, but it's similar in Germany, in Belgium, in UK, in Denmark, etc. Who owns the North Sea? So that really depends. If you are really close to shore, it's actually owned by the local government. If you get the further you go away from shore, the more the the ownership is transferred to a higher body. And that will create many challenges, mainly challenges with who has the first right of doing stuff. So, for example, this is a picture of the North Sea, again, the Dutch North Sea. And as you can see, there's almost no location where there's just one activity. There is a plethora of activities, like the ones over here. You have nature, shipping, oil and gas, fishery, sand extraction, dredging, the new one, wind energy. We have all sorts of cables and pipes running through it, connecting either our country or the activities that are being shown over here. You have a leisure component and also a large military aspect. So, for example, low flying areas for our F-35 Lightnings. I would like to stress three of them. The first one is nature, because by law and also by doing things that are okay, we need to take nature as a starting point, since many of the large parts of the North Sea are important nature areas, but also some of them are Nature 2000 areas, which are really valuable in the sense that they have a high amount of a habitat for big amounts of species, and are also mainly fragile. If you want to do anything in a Nature 2000 area, you need to follow the precautionary principle. You can only do a thing over there if you can know for sure that it has no adverse effects. And if it does have adverse effects, you need to compensate for it. So that's a really big starting point for doing stuff at the North Sea. A second one, as mentioned before, is oil and gas production. Even though it has been declining over the years, there has been, especially given the Ukraine crisis, a large ramp up in activities, and also new wells are being brought in production. So this will run for roughly 30 more years, with, as shown to the left, a large space consumption, and also has a drawback that you cannot go for multiple space use on these locations, because there's already a large oil and gas production plant. And there's also an opportunity that this will actually become bigger, because oil and gas is highly related to CO2 storage. There are many suitable offshore CO2 storage locations in the Netherlands or in the Dutch North Sea that might even complicate things a little bit further. Well, the third one I mentioned is the offshore wind development. Over here to the left, you can see the current and proposed offshore wind sites. As you can see, it's already quite a bit, already accounting for 21 gigawatts, but the ambition for 2050 is 72 gigawatts. On first, if you first look at it, you might say, there might be more than enough locations left, because it's only like 10% of the total area that you see over here. But do take notice that, for example, the reason that all the area between 1 and 2, 3, 4, and 6, etc., there are no offshore wind farms planned, is that there's no space whatsoever. So even though this does look like there's a lot of space, it's not the case. We really need to squeeze stuff in order to achieve this 72 gigawatts. These 72 gigawatts are definitely possible, but they need to come with some sacrifices on other fields. Offshore energy production and has a lot of challenges, also in line with the ones previously discussed on these mismatches. So a first one is mismatch in time. What we're doing, especially if we're creating large amounts of offshore wind, is that you have a really large peak production that might be, especially if we're going to 70 gigawatts, that might be up to 10 times higher than our average power consumption. So that will be a huge mismatch. On the other hand, if there's no wind blowing at the North Sea, you have a similar problem, but the other way around. There's also a mismatch in location. Many of these offshore wind production locations are far offshore, which leads to a very expensive infrastructure. And since the wind is not always blowing, this infrastructure is underutilized. A second one is, how can we service these kinds of wind farms, which sometimes serve in really challenging conditions, also during winter, etc. So servicing might become an issue. A third one is that we have a mismatch in function. Since if we're putting a lot of eggs into one basket, so that's the basket offshore, if we have a problem offshore, we won't have the stable energy system anymore. So that's one thing in function. So we don't have a functioning energy system anymore. And the second one is, if we produce lots and lots of electricity, we might only decarbonize parts of our consumers. For example, industry, especially the part of the industry that's going to create products, cannot be fed using electricity alone, at least not given the current approach. A solution here can be a conversion into hydrogen. And well, a lot has been said about it, but all of them have advantages and disadvantages. For example, you could try and make hydrogen inside a turbine. Good thing is that it's relatively easy to convert, because you can do some optimizations inside the turbine. You can even make the system much more simple. But distributed production, especially in an offshore location, might become challenging and expensive. And how will you come up with the ultra pure water that also needs to distribute to create this meshed infrastructure? You could also go for closer turbines, which is somewhat of an intermediate. Is easier to come up with, but does not have some of the advantages that inside a turbine might have. You might go for a platform, similar to how electricity is currently combined onto one substation. You could go for a substation that directly produces hydrogen. That could also be an island. With the disadvantage that you need additional infrastructure, additional investment, and you still need part of the electricity infrastructure. Finally, you can go for just on shore, is the easiest to come up with from especially starting point right now, but you lose all of the advantages mentioned before, and you still need an expensive infrastructure, an expensive electricity infrastructure offshore, which is also a challenge. The truth is, I don't know which one it's going to be, and therefore I think we should currently aim for all of them, especially since many of them are still in their infancy, and see which one can become most profitable later on. A solution that's highly related to this, also related to the solution of hydrogen, but also these faraway wind farms, is the development of energy islands, which can solve some of the challenges. So, for example, the fact that since you're so far away from shore, it's really hard to service, and it's really it will be really expensive to bring the energy on shore, and also might be a solution to your hydrogen solution. However, most of you will have a lot of challenges over here, because who owns this structure? There might actually be challenges in smuggling, etc., especially given Brexit. So this is also easier said than done. But overall, we're aiming for an integrated energy system in the North Sea that might look like this. The thing is, we don't know exactly what it will look like. We know the building blocks. We know the general direction, which is more wind offshore, more conversion into molecules, more integration between oil and gas and wind. But the end location is not sure yet. So over here, I've shown what you can all do, but it's so this is really an option for system integration, but we don't know the sizes over here. Currently, they're just, well, only mentioned, but we actually don't know if power to gas will become bigger or if we will go for the existing gas infrastructure, etc. So as long as we're not there, we should aim for betting on all of them, because we cannot afford to lose an important solution. So then I'll come to what is needed. The first one is we need research, we need development, we need to get our facts straight or straighter, like I discussed previously. We need a little bit of international coordination because, well, as the Netherlands, we're not in this as the Netherlands alone. The North Sea is one location and international coordination can be really important. A third one is that we need to invest in infrastructure, because infrastructure is I would say, a prerequisite for new developments. Because if you go for if the infrastructure is there, then the risk for developers, for people who want to come up with a new idea and want to develop a solution from TRL 1 to 10 or 9, lower risk will mean that people are more inclined to embark on a challenge. And finally, we need regulation also to de-risk. So it's all about getting a better overview using research, and on the other hand, de-risking all of the activities on the North Sea, because lower risk means also that people are more inclined. As mentioned before, a little bit about one of our big projects that wants to have at least some influence on this whole solution stuff. It's the North Sea Energy Project. It's a research program on energy system integration on the North Sea, and has a goal to create a clear pathway for system integration, and also finding answers to the challenges mentioned before, with focus points on energy hubs, on ecology, on logistics, on a roadmap, etc. So it's actually kind of well laid out and tackles most of the aspects that I've come up with during my presentation. And hopefully this will be a starting point for actual developments, investments, regulations, etc. But that's all still that's all still pending, and a lot of stuff needs to be done, both from a Dutch or country perspective, but also from a European perspective. But I think we're well underway, and I would say to be continued. But this is definitely a really challenging topic on the larger scale system integration. For the second part of our presentation, I'd like to give the floor to colleague Martijn, who will provide us with a similar story, also looking at challenges and possible solutions for small-scale energy system integration. I'd like to give the floor to Martijn.
Yes, thank you, Mark. And welcome to my part of the presentations, and nice to have you on during this in this webinar as participants. Mark already talked about the so-called energy trilemma in his presentation, which is mainly about finding a balance between security and affordability and sustainability of energy in the way we access and use energy in our daily lives. And I think that it's a very important one. But I'd like to start with another triangle that is presented on the slide, as you can see, which is perhaps a bit more well known, the so-called trias energetica. This is because it forms a number of important principles for shaping the energy transition and the role of system integration on a local scale. The trias energetica is about reducing energy consumption, reducing the use of fossil energy and in our energy mix, and increasing the share of sustainable energy. You might question, well, how does this trias energetica then relate to system integration on a local scale? Well, in order to give substance to the trias energetica and thus the energy transition on a local scale, Europe has focused on, among other things, the realization of the so-called PEDs, which are the positive energy districts. And when realizing these PEDs, and I come to that later on, the issues of system integration emerge very clearly, I think, and that is why I want to use the PEDs, the positive energy district, as a guideline in my presentation on system integration on a local scale. Can I see the next slide, please? Well, first of all, I think it's good to consider what PEDs exactly are. And I tried to summarize it. PEDs are, in the first place, energy efficient and energy flexible urban areas, groups of connected buildings. Second, they produce net zero greenhouse gas emissions, and they actively manage an annual local or regional surplus production of renewable energy. So to summarize it, in the end, on a local scale, it leads to a surplus of energy that is produced on a local scale. They also require something in order to be called a PED. It requires the integration of different systems and infrastructures. It also requires the interaction between buildings and the users and the regional energy mobility and ICT systems involved. And last but not least, it requires securing the energy supply and a good life for all in line with social, the economic, and the environmental sustainability. And as you can see in the picture, it may be a bit small, but I'll try to explain it. What you see on the picture on the top left, it says the idea is not that every home needs to have its own renewable energy production asset. Instead, what would be an ideal situation, optimal situation, would be a shift to a positive energy district approach, meaning that options should be available and choices should be made in terms of where to put these renewable energy production installations in the best possible way on a local scale. That would lead then to economies of scale, would also lead to smart distribution, optimal sizing, and optimal locations. Okay, next slide, please. When realizing PEDs, several challenges arise that make the objectives of the trias energetica challenging in practice, and which are also typical system integration issues. I would like to mention two of them, and one of them is the mismatch between energy production and energy consumption on a local scale, and the other one is the awareness that is required by people regarding energy use. Let me start by explaining shortly about the mismatch between local energy production and consumption. This one has been shortly touched upon by Mark already, but I'd like to bring a bit of focus on the local aspect of it. Given the fact that at district level you want to produce more energy than you will consume, one of the first logical questions, I think, is what to do with the surplus of energy that you generate. Well, in most cases, this concerns electrical energy simply because we can produce it in a relatively easy way on a local scale. And particularly nowadays, by using solar energy and wind energy. This surplus of energy can actually be used in two different ways. You can either feed it into the grid, or you can temporarily store it in a battery. Whereas the first option, to feed it in the grid, is the most commonly used method, which is still interesting, particularly in the Netherlands, since we here in the Netherlands have the possibility of what we call netting. However, that also leads to issues in terms of available capacity on the grid. And that's what we see nowadays more and more, also on the local scale. We see, I would call it, traffic jams on this grid due to the fact that locally generated power can and may no longer be fed in because the grid capacity is too small. As an alternative, there is the option to store the excess energy, excess electricity in batteries. However, we also see that this entails high investment costs. And for the moment, it's still an issue for people and organizations responsible for solving the issue of grid capacity to invest and bear the investment costs in batteries. So yeah, that's one of the main issues when it comes to setting up a PET and this specifically the mismatch that arises. Next slide, please. Another element from the trias energetica that plays an important role in the development of the positive energy districts is the possibility of energy saving on a local scale. And very important in this regard is not so much the technology or the technological development, but rather the awareness of citizens or other stakeholders that play an important role in the energy transition on a local scale. So how do you make people aware of their energy use, and what can you do to give them insight into energy saving options? And until recently, it played an important role that awareness of energy use was related to the fact that energy was a commodity product with a relatively low price. So in that regard, high energy consumption did not cause much financial pain on a personal or household level, so to say. And I think it's fair to say that this is changing quite a bit now because of several circumstances that we are all aware of, I think. And when it comes to awareness raising, and I'd like to go to the next slide, please. Is the option, and this also reflects on the trias energetica when it comes to energy savings, energy reduction. What we see in the Netherlands is that the share in the total energy consumption for the heating of homes is quite high. And just to illustrate it by a number, if you know that about 75% of the gas bill of an average household in the Netherlands relates to the heating of the home, and if you consider that about 2/3 of the homes in the Netherlands are poorly insulated, I think you can say that there's still a lot to gain. And until now, this has been considered as a fact by most homeowners. And with the rising energy prices, what you see immediately is that people are becoming aware of the energy use, also because they notice that they are bearing the financial consequences of that. And to mitigate that, they are taking measures to improve their use and also reduce the cost for energy. Right. So again, these are just two challenges that need to be overcome when it comes to this development of positive energy districts, for which I would like to go to a specific project that we as New Energy Coalition are working on, where also system integration plays an important role. That project is called Positive, and it's a project that deals with the development of positive energy buildings and districts, next to some other aspects, for instance, the e-mobility integration into the smart grid and energy storage and management, but also citizen engagement. So more the softer aspects of energy transition, which, by the way, play a very important role in setting up the positive energy districts. Next slide, please. Yeah. Just to give you a bit of background information here, the Positive project is a project that is a project within the framework of the Smart Cities and Communities framework of Horizon 2020 of the European Commission. And in this project, 2 so-called lighthouse cities are participating together with 6 fellow cities. And one of those lighthouse cities is the municipality, is the city of Alkmaar, led by the municipality of Alkmaar. And maybe that's good to underline here. This project started as a result of the ambition of the municipality of Alkmaar by signing the so-called SEAP, the Sustainable Energy Action Plan, in 2014, which meant that the municipality committed itself to the objectives of achieving a 20% CO2 reduction and using more sustainable energy compared to 2008, but also 20% compared to 2008. Next to that, the municipality also has the ambition to use 100% sustainable energy and be free of natural gas by 2050. The Positive project was actually, well, I wouldn't call it a kickoff, but it really was and is an important project to make the ambitions more concrete. And I'd like then now to focus on specifically the part of the Positive Energy District, because that plays an important role in the whole Positive project and meeting the objectives as set by the municipality. And I would like to name 2 specific sub-projects within Positive where we work on concretely with the partners, and just to illustrate what realizing a PET means in practice. And unfortunately, we don't have the time to go into this in depth, but I think my introduction to it just gives an impression and a good picture of how we work in Alkmaar in concrete terms on realizing the PET with the associated issues. So the first sub-project is called the Sports Complex De Meent, located in the Westrand area, because that's the name of the district. Then the Sports Complex De Meent is a sports complex where both indoor sports can be practiced, and where you also find a indoor ice rink and an outdoor ice rink, a long track, as we call it. And for this specific complex, the municipality has expressed the ambition to make the building more sustainable. In other words, to make it in the end completely fossil-free in terms of energy production, energy usage. So what does it mean then? What we did within the framework of the project, some solar PVs, well, quite a lot of solar PVs, I have to say, about 1,000, put on the roof of the ice rink. Those were actually already there before the project started, but in addition to that, and you can see that in the picture, also the parking lot has been covered by a whole set of PV panels. What you cannot see is that on the other side of the sports complex, also a bicycle shed has been covered by solar panels. So I think there's a total of 1,000 additional PV panels placed on the location. And these PV panels are then attached to a battery. And that battery then allows for optimize the electricity demand and supply by connecting the production of these panels to, for instance, the lamppost, but also to some charging points that are located on the parking lot, and heat pumps. Those are just some means where the electricity is being used for, but also in general terms, the electricity produced is mainly used to well, basically power all the assets that need power on the location. Next to that, there's also an investment or a project, a sub-project focusing on the establishment of a low temperature waste heat of on the location, making use of the ice machines. And well, for this specifically for the icing rinks, these machines, although they produce cold, they at the same time also produce heat. And this heat, up till let's say about a year ago, was not used in a good manner. It was just blown away. And now, by doing some smart investments, this heat is also serves as a source for the heat pumps, as I mentioned before. Next to that, that heat also balances the temperature fluctuations of a so-called aquifer system that's being part of the positive project in Alkmaar. So there's an aquifer system is a system that is being placed in the ground to store heat and cold, and to interact with fluid streams in the bottom, and use that temperature and exchange temperature differences in order to either heat or cool the location. And the picture that is shown on the bottom on the right indicates an initial plan of the distribution of the heat, not only for the sports complex itself, which is indicated in yellow mainly, but also, if possible, and that's still that's dependent on the available capacity, to distribute that heat to other locations close to the sports complex. So I think this is a very good illustration of how these kind of networks not only can help making the specific location more sustainable, but also adjacent locations. Then another sub-project in the positive project is the Volvat high-rise. The high-rise is a 10-story building, also in the Westrand area. And there, as you can see on the picture, that's an artist impression. On top of that building, a huge PV installation will be constructed and will be commissioned presumably by the end of this year or the start of the next year. And next to that, also the southern facade of the building, on that side, there will also be PV panels installed. In the end, the electricity to be produced on an annual scale will be about approximately 250,000 kilowatt hours, which then will be sufficient for the energy demand, the power demand for the whole building block. But as you can imagine, particularly during sunny days in summertime, the demand for electricity will not balance the production. And in order to overcome what I earlier described, the grid congestion issues, a battery will also be placed to store this electricity and to potentially use it in a later time. What I just described are all mainly technical aspects. Just as important here are non-technical aspects, and in this regard I would like to mention that the involvement of the tenants living in the high-rise building has been very important. Before starting this initiative by the Housing Corporation, all tenants were inquired and asked about their ideas about this concept, and they were they were in the position to reflect on it, and that input has been used by the Housing Corporation, and well, in the end they came up with this idea that has been approved by all tenants, or at least the majority of the tenants, I have to say. Yeah, can we go to the next slide, please? Yeah, again, as I said, there is a people tend to look at specifically the technical aspects when it comes to realizing these positive energy districts. We see that a lot. There's a very strong focus in positive as well on implementing technical and innovative elements on various locations. But a study conducted by the University of Delft showed that actually there are far more aspects relevant when it comes to realizing PETs, several factors. In fact, there are 7. And those 7 I depicted in the slide here. So we have governance, we have incentives, we have social and process, market, technology, and context. And as I said, technology is only one of them. And just to illustrate, I'm not going to into all details of these various aspects, but just to illustrate what is meant, for instance, by governance. It's about new and innovative forms of collaborative governance in this case. So when you talk about the realization of PETs, also the development of, for instance, sustainability plans together with citizens in that regard is important. That's just an example of the importance of governance. And in relation to, for instance, technology, I'd like to come back to that once more, is then how can we apply new technology to balance offer and demand for for these PETs. So yeah, again, there are several factors that needs to be taken into account when developing a PET. Okay, next slide, please. So yeah, I started my presentation with showing the trias energetica, and what we have learned so far already is that actually there's still one part in this trias energetica that we think should be replaced in the end, and which is the fossil fuels part. So instead of that one, I would say let's focus on, first of all, the use of remote renewable resources, and as depicted in the blue triangle here, the smaller one, use on-site renewable sources. And I think for that, the PETs are really relevant and provide additional and added value to the whole concept. Okay, that's it.
All right, thank you, Martijn, for your insightful presentation. If you have, as an attendant, first of all, thank you for attending. If you have some questions on this lecture or want to discuss a little bit further, our contact details are given over here. This has been part of a webinar series of the New Energy Business School. The New Energy Business School, besides webinars, is also organizing courses which shed somewhat of more of a light on different topics. For example, system integration, but also on hydrogen, on grid operators, on energy strategy, etc. So if you're interested, please check out the website and get into contact with us. I think we still have a little bit time left for questions. If you have a question, you can add it in the chat for now. But I already, during the presentation that Martijn had somewhat of a remark, because Martijn, you mentioned that we're doing a lot of demos on PEDs that finally need to come up with this new trias energetica, which is all about, first of all, doing saving, then doing things local, and then doing things from afar. But what do you think should, for example, a Dutch government or a European government do right now in order to speed up the implementation and also use the lessons learned from your demo?
Yeah, that's a good question. I think that is something that is specifically when it comes to this European project is already been taken care of by the project itself, so to say. It's embedded in the project. So the European Commission, for instance, says, well, if you want to execute this kind of project, these smart cities and community projects, you have to consider how you want to roll out the experience that you gain from it. So it's not just about demonstrating it on a local scale. It's also about in the project itself, on that, in this case, the Westland area. It's also about define and plan on how to roll out this concept and the lessons learned regarding the various innovations that you're demonstrating, either in your own city, but in other parts of the city, as well as in other cities. And it's specifically that, and that's specifically the reason for having fellow cities on board as well, because they are also interested in, okay, what are you specifically demonstrating and testing in Alkmaar, and to what extent can that be of interest for our city and the needs that we have. And last but not least, one of the tasks that we are responsible for together with the consortium in Alkmaar is the definition of a so-called bold city vision plan towards 2050. So meaning we have to describe what it is exactly that we learned from the demos itself, but also how are we going to incorporate that in a broader vision towards making the city not just more sustainable, but even more smart.
Right. Thank you very much, Martijn. Any questions from the audience? Okay, if there are no questions from the audience left, then I think we can finalize this webinar 3 minutes before the final deadline. As mentioned, if you have any questions to us or want to have a discussion, please contact us. I'd like to say a really nice afternoon for you, and thank you for attending. And I hope to see you in the next webinar by the New Energy Business School. Thank you.
Thank you. Bye-bye.